So in the last 3 videos we've dealt with counting functions, then injective functions, then surjective functions, and finally we reach bijective functions. Okay, these tend to be slightly easier than some of the other ones, but anyway, let's go. We're going to do 2 JEE Main questions here. Let's just go through again what a function is. So a function, every element in the input domain has to match with exactly one element in the output codomain. A bijective function is both injective, as we've discussed in the previous video, and surjective, which practically speaking means 2 sets are the same size. If it's bijective. So let's say, for example, we had 1, 2, 3, 4 and 5 in here, 1, 2, 3, 4 and 5 in here, or whatever. This one here has 5 choices of what to go to, and this one here has 4 because it's got to be different because it's injective and surjective, and this one here has 3 choices, this here has 2 choices, and this here only has 1 choice. So the number of possible bijections when the set has 5 elements is 5 factorial, which equals 120. When the set has n elements, the number of bijections given no constraints will be n factorial. Of course, it's never as easy as that, and there are constraints. So let's have a look at the 2 questions. Here's the first one. JEE Main, July 2022, Shift 2. Anyone who wishes to have a go at this, pause the video. Okay, right, so the number of bijective functions, which takes us from this domain, 1, 3, 5, 7, 99, the odd numbers up to 99, to this, the codomain, which is 2, 4, 6, 8, all of the even numbers up to 100, such that we have this constraint here, is how many? Okay, so what we got to do, well, basically what we need to do is we need to look at how many elements are there in the domain, and how many are there in the codomain. Well, there's clearly 50 in each. There are 50 odd numbers between 1 and 100, and there are 50 even numbers between 1 and 100. So if we just looked at the 2 sets here, and we got 50 elements in here, and we got 50 elements in here, what we could say is that basically there are 50 factorial possible functions between those 2, but that's if there isn't the constraint. Now, with the constraint, basically 17 factorial, because there are 17 in here, 3, 9, 15, 21, up to 99 is 17, because basically 99 take away 3 is 96, and when we divide that by 6, because there's 6 between them, that equals 16, and of course then we have to add 1, and so therefore there are 17 of these elements in the constraint. So as they are only allowed, instead of having 17 factorial possible permutations, they're only allowed to have 1, which is this order, where f of 3 must be greater than f of 9, which must be greater than f of 15, which must be greater than f of 21, and we can ignore the equals, by the way, because this is a bijective function. Then the answer is 50 factorial over 17 factorial, which is the same thing as 50p 33, remembering that mpn is equal to m factorial over m minus n factorial. So the answer is B, 50p 33. Another way of looking at this, which I find actually makes it slightly easier, is let us just look at the set, that part of the domain which is not including 3, 9, 15, 21, etc. So that would be 1, 5, 7, 11, blah, 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 all the way up to 97. And let's have a look at the codomain, which would be, let's just as it is, 2, 4, 6, 8, all the way up to 100. Well, this first element here has a choice of 50, and this second element here has a choice of 49, because remember it's still going to be injective, so it can't choose the same one. This one's got 48, blah blah blah, and this one here, as there are 33 elements here which are not 3, 9, 15, 21, this one here has 33. Okay, so that would be 50 times 49 times times 33, which equals 50 factorial over 17 factorial. And then when we look at 3, 9, 15, 21 and 99, etc., etc., they will fill the other 17 which are left here, regardless of what the 17 are, and they have to fill them in the only order that they can, which is that 3 must map to the biggest, 9 must map to the second biggest, 15 must map to the third biggest, and there's only one way to do that. So the total number of bijective functions is still, again, 50 factorial over 17 factorial, which is 50p33. Depends how you want to look at it. Okay, so that's the first question, and here's the second question. Anybody who wishes to have a go, please pause the video. Okay, so now this one actually says it's an onto or surjective function. So you might think, well, what's this doing in a bijective video? Well, in actual fact, as the function goes from S to S, we know that S, the domain, and S, the codomain, are the same size, and therefore we know that any onto surjective function is also bijective. And given that in the previous video we saw that dealing with onto functions where the size of the domain and codomain are not the same is actually quite difficult, if they are the same, don't bother worrying about it being onto, just assume it's bijective, which it is, which makes it much easier. Okay, so basically we have a restriction here that G3 equals 2G1, and we need to work out the probability a random chosen onto function from S to S satisfies that. Okay, there are constraints only on 3 and 1, so let's have a look. So basically, let's have a look at G3. Well, let's say it could be 1, 2, 3, 4, 5, or 6. And then G1 would be whatever. Right now, for G3 to be twice G1, well, clearly G3 can't be 1, can't be 3, and it can't be 5. If 3 maps to 2, then 1 must map to 1. If 3 maps to 4, then 1 must map to 2. And if 3 maps to 6, then 1 must map to 3. So there are only 3 possibilities regarding 1 and 3 that satisfy this constraint here. Okay, but what about the other 4 numbers, which would be 2, 4, 5, and 6? Well, the other 4 numbers, there are no constraints. So basically, one of those numbers can map to any of the 4 numbers left. So that's 4, and the next one maps to 3, and the next one maps to 2, and the next one can map to 1. So that's 4 factorial. And so therefore, the total number of surjective functions satisfying this is 4 factorial times 3, which is 72. And now to work out the probability, we need to see the total number of surjective or bijective functions from S to S. Well, we've already worked out the total number of bijective functions of a set size 6 is 6 factorial, which equals 720. And therefore, the probability that it satisfies this constraint is 72 over 720, which equals 1/10, which is answer A. Okay, so the bijective ones, to finish off this this little series of videos on counting functions, are relatively straightforward. You just have to keep your wits about you. I hope you found these all useful. If you have, please like the video and subscribe to the Gresty Academy YouTube channel. Thank you.